Hi everyone. In this video we're going to be discussing how to work with alternating series tests as well as finding error for alternating series. Now, if you remember in a previous lesson, whenever we're working with alternating series, we know it's an alternating series whenever you notice it's -1 raised to a power, meaning n-1 or just n. Now, if you notice that it is -1 raised to a power and you notice it's alternating series, the only way that we can determine whether this is going to converge or diverge is by the alternating series test. Now, in order to prove that it's going to converge or diverge, you need to prove two things. You have to prove that this is a decreasing function, meaning that the next term is less than the previous term, as well as finding the limit as n approaches infinity of the function. And what I mean by that is the alternating series test multiplied by a function and take the limit of the function as it approaches 0, and if it equals 0 and it's decreasing, then the series is going to converge, and if not, it's going to diverge. So let's just go ahead and do an example. Alternating series test is an easier test opposed to all the other ones. So when you're looking at this, the first thing you have to notice is this an alternating series test? Obviously it is because we're doing it, but the reason is it's -n raised to n-1. So your first step is to break this apart because you need to find your a of n. So because this is an alternating series test, I'm going to take the alternating series out, and this is going to be multiplied by 1 over 3 to the n, which will still be the same thing. If I multiply this in, I'm going to get that. So then my next thing is, okay, well, I now know that a of n is equal to 1 over 3n. So then what I'm going to do is, it doesn't matter if you do the decreasing or the limit of a of n first, as long as you do both. I'm going to do the limit, because if you do the limit as n approaches infinity, it is a little bit easier than to determine if something is decreasing. So once I have that, I know that if I plug this in, I'm going to get 1 over infinity, which is equal to 0. That checks out. Awesome. So step 1 is completed. Now my next step is I have to figure out if this is decreasing, meaning that my next term is going to be less than my previous term. Well, there's two ways. Whenever you're determining if it's decreasing, this goes back to like the integral test. When you determine if something is decreasing, you could apply the first derivative, find your critical numbers, find the undefined points, set a number line, determine where it's decreasing. Or you can take n plus 1 and plug it into the equation. So that's going to be, which is less than the original equation, and you have to determine if this is true. One way you know this is true is because any number I plug into n, this is always going to be less than, because my denominator is going to be always bigger than this denominator. Another way you could work this out, you can cross multiply 3n, which is less than 3n plus 1. Simplify, this cancels out, so I'm left with 0 is less than 1. Is that true? The fact that this is true checks out. So there's many ways of determining something's decreasing. You can plug n plus 1 and solve it. You could do you can do the decreasing test. So find your first derivative, put a number line, determine if it's decreasing. As long as you determine it's decreasing and limit equals 0, this checks out. So that means that your summation from n equals to 1 of infinity of -1 raised to the n-1 over 3n will converge by the alternating series test. And it's really important that you explain the reason why or which test you used. Okay? So step 1, break it apart. Step 2, find a limit as n approaches infinity of a of n, and it has to give you 0. Step 3, make sure that it's a decreasing function, and if these two are true, then it's going to converge. So let's move on to the next one. Now for the next one, same thing. I notice it's -1 to the n, so I'm going to break it apart. Step 1, break it apart. Step 2, find a limit as n approaches infinity of your a of n. And then you plug it in, infinity over infinity. That doesn't really help me out, so I'm going to do L'Hopital's rule. That's going to give me 3 over 4. And that is my limit, but that does not give me 0. So because of that, I don't even have to determine if this is decreasing, because I know the summation from n equals 1 to infinity of -1 to the n, 3n all over 4n minus 1 will diverge. Because of alternating series test. So alternating series test is easy. It's one of those where you break it apart once you know it's alternating series, find a limit, And if it doesn't give you 0, stop right there. There's no reason why to keep on going with this. Okay. Next thing. Sometimes you're going to have a difficult problem determining something's decreasing. And because of that, that's what's going to create this to be a little bit longer. So, last alternating series test, -1 raised to n-1 checks out. So then, this lets me know I got to break it apart. Step 1, break it apart. Figure out what your A of n is. And I'm just going to go ahead and rewrite it. Then I'm going to determine the limit of my A of n. I'll plug infinity, but that gives me infinity over infinity. Doesn't help me out, so that means I have to do L'Hopital's rule. And if I do L'Hopital's rule, the derivative of the top is going to be bring the half to the front, keep this the same, subtract by 1, and then chain rule it. So this is going to actually be 1/2, and then plus 1 on the bottom, times the derivative of the bottom, which is 1. This just simplifies to give me 1 over 2 square root n plus 1. If you plug infinity into that, you get 1 over infinity, gives you 0. So this checks out. Now your second step is you have to determine if it's decreasing. Okay, now in this problem, it's a little bit difficult to plug in n plus 1 because of the fact that there's a square root. So because of that, you should just go right ahead and do a derivative. So in this case, since it's a quotient rule, it will be low d high minus high d low. So when I find my derivative of this, low times the derivative of the high minus high derivative of the low, which is just 1. And now you have to ask yourself, okay, subtract by 1, I forgot to do that. So low, derivative of the high, bring the half over, keep this the same, subtract by 1, chain rule the inside, but that's just going to give you 1, so I'm not going to write it, minus high, derivative of the low. So then you have to ask yourself, can I factor something out? I can. This is identical to that. So then I'm going to take out n plus 1 to the negative half, and I'm going to be left with okay. Then I'm going to simplify this. This can get simplified to give me n plus 1 to the negative half and then combine like terms, and when you combine like terms, this is going to give you n plus 1 to negative half, negative 1/2, minus 3/2. Now, I am done with the top because this was low d high, and this is the hardest type of derivative whenever you have to factor out an LCD. Now I can finally put this over low squared, which is the bottom squared. And then I'll bring this down to join it. So this is now going to become negative n minus 3 over 2 because this is LCD all over. If I bring this down, this is going to become n minus 1 to the 5/2. Then I'll keep change flip. Y prime is going to equal to negative n minus 3 all over 2n minus 1 5/2. Now your next step, once you have that, this is your derivative. Like I said before, the hardest part in a problem like this is determining if it's decreasing because of the derivative. I'm going to put numbers on a number line, find your critical numbers on top. Your critical number on top is going to be negative 3, and the number on the bottom is going to be 1. These are your boundary points. You need to test your intervals. Now, this is the thing that you have to remember. My series goes from 2 to infinity, so it doesn't really matter if I plug a number less than negative 3. Doesn't matter if I plug a number between negative 3 and 1. What I care about is 2 to infinity. So I'll plug in 2 into my derivative. Now, when I plug into my derivative, I'm going to get negative 2 minus 3, which is a negative, over, I'm going to plug 2 into the bottom. 2 minus 1 is positive. Raised to 5/2, still positive. So this is going to be a negative, meaning it's going to be decreasing, which is perfect, which is what I wanted. So it's going to be decreasing from 1 to infinity. So this checks out. Was it complicated? Yes. This was all complicated. This was very complicated because of the derivative. But anytime you need to determine if something is decreasing, you have to apply a derivative. So then, because it was the limit was equal to 0 and the derivative was decreasing, I know that this now from n equals 2 to infinity of -1 n minus 1 n plus 1 all over n minus 1 converges because of alternating series test. This is a complicated one, but as long as you stay organized and you're able to find your derivative, you're going to be fine. Okay, so that is how you apply the alternating series test. For the majority of the problems, it's going to be easy, but for the one that you have a complicated derivative, it will be a little bit harder. Now getting to our last problem, and that is finding error. Now the only time you could ever find error is if it passes the alternating series test, meaning that it has to be an alternating series in order for us to find error. Now the one thing that we can notice is the fact that it's -1 raised to n plus 1. This is definitely alternating series form, so I'm going to rewrite this. Okay, now I know a of n is equal to 1 over n exclamation point. Remember, n exclamation point is n factorial. So when you see that, don't freak out. It just means that it is just a factorial. So our next thing is we want to approximate the first 5 terms. That's the formula. Error is found by the sum minus the partial sum, so whatever number of terms we're asking to find, which in this case is 5, which has to be less than the next term. So after the 5th term is the 6th term, and that's what we're going to find. So when you notice this, the first thing you have to do in order for us to actually determine the error, it has to pass the alternating series test. So once I found a of n, limit as n approaches infinity of a of n is going to equal to 1 over infinity factorial, which is definitely going to give you 0, so this checks off. So then the second one is, okay, determine if it's decreasing. So remember, decreasing, sometimes you can find a derivative. I cannot find a derivative of that. So that means I have to determine if n plus 1 is less than a of n. So I'm going to plug n plus 1 into there, which has to be less than my original, which this makes sense because remember, this denominator is always going to be bigger than that, and that's going to always be smaller. So that's going to check out. So it's decreasing. So this definitely converges. So because it converges and it passes alternating series test, I can go ahead and determine everything else. So in order to find error, in order to find the 5 terms, I'm going to do R of 5, which has to equal to the sum, which I have no idea, but I'm going to find the partial sum of the first 5 terms. And this has to be less than a of 6, because when I plug 5 into n plus 1, I'm going to get a of 6. So when you notice that, you're going to go, okay, well, first thing I need to do, I need to find that partial sum. So I need to plug in 5. You got to remember that I'm starting off on my second term, so I'm going to plug 2 into my factorial, into here, and I'm going to get -1/2. Then you're going to take n equals to 3, plug it into here, -1, 3 plus 1 over 3 factorial. This is going to be 1/6, and then finishing them all off, I'm going to get -1/24 plus 1 over 120 minus 1 over 720. And this is going to combine to give me -53 over 144. So my partial sum of the first 5 terms is going to be -53 over 144. Remember, what we're doing is we're taking our second term, third term, fourth term, the first 5 terms, plug it into the original series, and we're going to get these numbers, add them up, you get that. So now I know that S minus -53 over 144 has to be less than my 6th term. So that means I'm going to plug 6 into my series, and that's going to get 1 over 5,040. And that right there is your formula. That's your error. So then what you need to go ahead and do is, well, this is going to create 2 problems. This is going to create, because the fact that you're working with an absolute value, this is going to give you S plus 53 over 144, which is less than or equal to 1 over 5040, as well as S plus 53 over 144, which is greater than or equal to -1 over 5040. And then you could turn these into decimals or work with fractions. When you subtract this, it's going to give you s is less than negative 103 over 280. And this is going to give you s is greater than or equal to negative 116 over 315. And the error is between this. Okay? And that's how you find error. So whenever you find error, the first thing that you need to do is you need to first determine if this is going to converge, which we found out that it does. We broke it apart. We found the limit of A of n, and we saw that it was decreasing. So this converges. So awesome. We know it's going to converge to some number. And then the next thing that we have to figure out is, okay, in order to find the error, we have to follow this formula. This formula is the sum, the absolute value of the sum minus the partial sum of whatever number of terms they're going to give us. They're going to tell us the number of terms. Find the partial sums, plug it into your original series, and add them all up. So it's going to be s, the sum, minus the partial sum, which has to be less than the next term, which is a of 6. So plug in 6 into there. And this absolute value problem, make one positive, flip the sign, make it negative, combine, and it's between here. And that is going to be the error of this problem. Okay? So, alternating series test is not going to give you a sum like the other equations. It's only going to tell you if it's going to converge or diverge. And if you need to find the error, the only way that we can do that is we have to first determine if the alternating series test converges. And if it does, then we can do this. Okay? So, hope to help. Thank you for watching, and let me know how it went.